Let's again once keep on doing some exercise regarding how to locate elements and elements in the periodic table based on their electron configuration. So for each of the following, identify the block. So we are expected to indicate the block and the period, group, and group name. If there is a group name, let's indicate where appropriate. Element's name, what's the element name? Element type means metal, non-metal, so we are going to state this one. So to answer, first of all, let's make a table so that, let's say block, period, group, group name, so group name, group 4, elements name, element name, name of the element, element's name, and the type of the element. Is it metal, metalloid, or non-metal? So let's see one by one. We have this expression, which is A, the condensed form, which is in our noble gas notation, 2s2, 2p5. What we are concerned is simply the last configuration. Both of them are in the same main energy level, and the last electron goes to the p orbital. The last electron goes to p orbital. So since the last electron is in p, we call it p block. So the block is p. And the period, in order to know the period, simply the outermost shell. So the inside, the second shell, here is the outermost shell. So it is period 2. Group is simply adding the electrons in the outermost shell, which means the outermost shell S and P. In the outermost shell, we have 2 in the S and P, 5 in the P. So add them together. So 2 plus 5 is equal to 7, group 7. Or group 17 if we have a transition method expression. But since it is P block, S block and P block, we consider them like group 7 or 17 or 17. If we are considering transition metal, we have 17. But if we are skipping transition metal and count the representative elements, we can have group 7 or 17. So to make it very precise, because this tells us group 7, because you just add 2 plus 5, group 7. Any p block elements can be the group number indicated by adding 2 plus 5. Simply the electron in S and the P. Element's name is, if you see the periodic table, you have group 7, so it will be fluorine because it is a 9. The first, it is fluorine. Fluorine is non-metal. Non-metal. So I have to clearly write this stuff. It is non-metal. Non-metal. This is all about A, and when you come to B, let's choose the configuration. Configuration is argon 3d10 and 4s1. So still don't forget this relation. Does this configuration obeys n minus 1d and ns? Let's check. Where n is, you start from the outer shell 4, 4 minus 1 is 3. So this is D block. So transition metal. So the block is D. If you see argon, the atomic number for argon is 18. Up to here it is 18. 18. So 18 plus 10, 28. 28 plus 1, it is 29. So this element has got 29 electrons, or 29 protons. An element which has 29 proton is what we call it copper. Copper. So copper is a D block. So we have to indicate the period. The period is indicated by simply the outermost shell. The outermost shell is this one. So the outermost shell is 4. So it is period 4. And if in group you simply add the electrons, these electron and these electron, add them together so that you will have group 11. And element's name is copper. Copper. It's definitely it's a metal. Metal. So these are the information we can extract from the equations, from the questions given. So let's summarize the electron configuration, especially those elements in D block. So D block group, unlike those in S block and P groups, do not necessarily have identical outer electron configuration. So let's summarize by stating this point. The D block groups, the D block groups, unlike those in S and P block, groups do not necessarily have identical outer electron configuration. So with this statement will lead us electron configuration. So we can mention examples like if we have nickel, the electron configuration is simply, let's briefly summarize it, argon 3d8 4s2. And if we have palladium, we have krypton 4d10 5s0, and platinum we have xenon 4f14 5d9 6s1. Now I want you to consider these three examples to the above summary. It says D block groups, unlike those in S and P block groups, do not necessarily have identical outer electron. What is the outer electron here? The outer electron is this one, in the case of neon. And the outer electron in the case of palladium is this one. And platinum, this one. So as you can see, in all of the cases, the outer electron is different. But we cannot right away jump to say, had it been S and P block, we can simply say it's S block, S block. But since it has always D and S together, D and S together, D and S together, with what pattern? N minus 1 D and NS. If it fulfills this pattern, so it's transition metal. So with this, all of them are transition, because my N is always the outermost shell. This is the outermost shell, N, 5. So 5 minus 1 is 4. The outermost shell is 6. 6 minus 1 is 5. Here the outermost shell is 4. 4 minus 1 is 3 here. So all of them are transition metals. But if we are assigning to group, if we are asked to assign group, the group number is indicated. For this one, the group number is simply add the electron 8 plus 2, it is group 10. And 10 plus 0 is, for the second one, is also group 10. And the third one is 9 plus 1, it is group 10. So all of them, even though their outermost shell, they are unlike those in S&P block groups, do not necessarily have identical outer electron, which is true. In the case of S block and P block, they must have the same number of electrons in the outermost shell to say they are in the same group. But unlike that one, in the D, simply you add the two successive shells containing S and D together, so you end up with the same group. So if you refer your periodic table, you will find nickel in group 10, palladium in group 10, and platinum in group 10.